All right, so we are on Section 4, so Week 1. This is the Friday, the Video02. Looks like we just went over the whole carding game in general and the more simpler scenes of more UI-based intro, lose, win. And then went over the main scene in the physics playground. Then we really just went down, focused on the player game object. And we opened it up and we looked underneath and looked at the animator and animations for the cart and the player. And kind of poked around and looked at saw that there were a bunch of physics colliders on some of these objects. And then we just looked at kind of the root here. We got a rigid body, we got an arcade cart. We haven't looked at the player animation scripts. We did look at the keyboard input just to see, because that's usually the starting point. And then we really focused on the arcade cart. And let's talk about how we have this like internal class here that's stat power-ups. So if you get a power-up, what's the new type of modifier like? How long? What's the ID? How long does it last? And then we have this struct stats, so all the main stats of the player. And within the stats struct, and there was this operator, how to add one stat plus another stat, and the whole definition is here. And it's secretly a method, but you could just say like, give me, this object plus that object and type stats, and it knows what to do. It'll return back this new stat. It looks like we have some properties here that are read-only. And the base stats to start off with, which are the struct stats, and they set them all. But the interesting thing is that since it's serializable, we do get to see it out in the inspector and tweak it as need be. And so a bunch of more properties that can be set up on the inspector, and then we have down here some fields and some quick little methods for setting properties for fields. And I don't think I kind of went through these because first, I don't like to just jump into methods. Usually I like to just look at like the start or the awake. So we went through this. Update suspension parameters for each wheel. I was just doing the settings for that physics, that wheel physics collider. And okay, so we do add spark, add trails, just add a bunch of prefabs to the rear wheels for drifting. And the fixed update was going to definitely, let me just take a quick look. It's going to be a big one. It's probably going to call a bunch of these other methods. And then we do have some physics stuff down here. On collision enter, on collision exit, on collision stay. So we do have a rigid body. But where is... Usually when there's a rigid body, I'm used to seeing a collider on the same level. Like there is this capsule collider underneath here. But normally when you see on collision enter, exit, and stay, normally there's like a collider at the same level on the same game object. And that's why you can write out these model behavior inherited methods, and it'll connect up with whatever collider is on the same game object. I'm familiar with that. Let me come back to this. So MoveVehicle, it's going to be a really big one. Yeah, it's like the main part. Alright, so I gotta go back to fixed update, but maybe is there some collider that gets created procedurally? I just don't see it right now. Let me just click play real quick and see if just a collider gets added on this game object. Maybe if there's a rigid body, but there's no collider, that the rigid body acts as a basic collider. No. I'm gonna guess it's this capsule collider here. I'm gonna do a little test first. Let me just do some print statements here, just to see if I can see who's calling this, because it's not very clear to me. So on collision, enter. As collision true. Just since it's like this little one-liner thing. Oh, you know what? I can still do a little. It was like this little anonymous one-liner thing. I was gonna make a bigger line. I don't need to do that. Just debug that log. And the collision object that comes in right here. Oh, is my IntelliSense still not working? Yeah. Auto behavior. Sucks. I like had to reset my computer. And ever since I did that. Hold on one second. Pretty sure I'm all set up. Let's check if the unique plugin, because then it helps me like what methods or properties are connected with each object. Yeah, he's turned on. Telecode. And we're just double check over here. Yeah, this one keeps kind of being reset. It's kind of weird. Let me close this out. Okay. Try generating. I'll try it. I might have to like reset Unity. In the meantime, I guess I'll just like read the API. And I look at what a collision object gives me. Okay. Describes a collision. The collider we hit, the rigid body of the collider that your rigid body collides with the other side. What about my side? Everything's about what we hit. I kind of want to see who I am, which is a unique situation. Like who's the collider that's... It's not going to give me what I need. It's all about the other collider. So I was trying to troubleshoot like whose collider is this using. Cool. At least my IntelliSense is working now. You see this collision is green now, so cool. That's all set up. And just to check that, just be like collision dot Okay, yes. Perfect. Yeah, tell about what you're hitting, because you're supposed to already know about yourself. Alright, but at least I fixed that. Fix my tail code. I just want to turn this capsule off. So what I want to do is, instead of that, I want to do debug.log. Just doesn't matter. I just want to print something to see if a collision happens. Or maybe it's like all the colliders that are underneath. We got wheel colliders, we have colliders under here, and we have this maybe all of them register with the rigid body. Oh, that's rebuilding. Let's take a look. Yeah, colliders on a game object that has a rigid body and those dynamic colliders. Oh, rigid body is already a collider. No, is a game object that has a collider and a rigid body. If one game object has a rigid body but no collider, it passes through other game objects and Unity does not include it in collision calculations. Okay, yeah, these might just be empty collision methods that don't even do anything. Let me just take a quick look. I went this far in. Let me see if it prints anything. Nope. They definitely prints. All right, so my next guess is, let me turn off this collider. My next guess is that it's feeding in, if there's no collider with the rigid body, it just looks at the game objects underneath and tries and grabs anyone to associate with, or maybe any of the colliders underneath. I'm not finding a straight answer on the internet right now. Yep. Still hitting. So let me go into these wheels. Yeah, I'm going to turn off the collider. I don't know if this just means the car won't even move, but let me see. So now all I got going on here are these wheel colliders, which are these circle things, but I think let me just, at some point I'm not going to be able to move, because I'm just like, I know that colliders are, I think these are colliders that do an acceleration to the car. Whoa! Huh, interesting. Not sure why, but it's giving me a jumping effect. But I'm noticing I am hitting the road. I'm jumping on the road. And I'm getting no printouts. So, alright, that answered my question. Yeah, like I'm hitting the wall right now. I'm getting no printouts. So, looks like when you don't have any colliders. So I'm just going to turn these on, and I'm going to leave this one off just to confirm my hypothesis. Let me just see if, flipping around, see if I get a printout. Yep, you get a Okay. So rigid body jumps down and grabs any collider underneath it. So that was interesting. There's nothing in documentation or the internet search really talked about that, and I've never seen a rigid body by itself. So that's interesting. Make note of that. So rigid body at one level, and there is a script on that same level, the same game object that has collision methods that are coming from MoveVehicle, and there's no collider anywhere I can see, and so it definitely goes down into the hierarchy underneath it and attempts to find any collider and associate with these methods. And okay, so that was a little bit of a rabbit hole, but unusual setup and interesting findings. So fixed update. So go through and update suspension params. So okay, for some reason this was something I had an issue with before. It's always setting these, like you're supposed to set stuff and initialize stuff in the once, not over and over again. So I don't like the fact, unless these are being tweaked somewhere else, but I don't think they are. So I'm just gonna comment them out real quick. Be like, that's wasted processing, but I'm not sure about that. So let me check. See if he drives the same. Yep, driving the same. Wasted processing. Huh. So you only need to set the parameters on these wheel colliders once in the update. You'll need to do it every in the awake. You'll need to do it all the time in the fixed update. All right, gather inputs. This was another wasted area, if I remember. Yeah, he was just like recreating the struct over and over again. It's annoying. But anyway, so what's happening is you get new input data. So you get a new struct, remember, accelerate, brake, turn, into, sure. Oh, this is over in base input. All right. And if you want drift, always set this to false to start off our update, because we don't know if we want to go into a drift. And then go through, this is like if there was more than, okay, remember now, more than one input component on this game object, which there's not. There's just one. So generate input for that one, which was like accelerate, brake, turn. It then wants to drift. Okay, so if you're braking, which is like the back arrow, and remember we went over the dot product. So whatever the velocity of your rigid body is, dot it with your local forward. And if that dot is greater than 0, interesting. So it's like whatever direction you're going, I would figure drift would be, if you're braking and your velocity dot your local forward is 1, they're both going in the same direction, I would figure that's not a drift. I would figure drifting is when it's like 0, when they're like in parallel. So what this means is like they have join tool. Last time I tried to annotate on here, everyone said it was kind of hard to read. It looks pretty easy to read, but let's just say I'm driving. So my transform forward just means what's my local forward. So if this is my cart, right, and this is the road, my local forward is this way. All right. And if my cart is turning, it's just saying where is the actual local forward, because the cart is built with along the z-axis. That's just a convention. So if I go to the game here, this cart, notice, click on cart, the blue arrow is positive z, the cart's forward that way, and I'm in local space. And I could even rotate this thing. It just happens to align with global right now, but let's just say he's moving and turning, right? Global z is this way, I've turned off of it. But if I look at local, my local forward, it's in the direction of the cart. So that's what I'm trying to draw. So that's what transform forward is. So it's just saying where is the cart directed right now? And so it's like, this is the cart, this is my forward, my local forward. And it's saying, what's my velocity dotting this? So if I'm going forward in this way and I'm just pressing the up arrow, right? And my velocity matches because I'm just pressing W up and my cart happens to be aligned with it. We dot these two, they're going in the same direction. We're going to get a dot of 1, right? And if my cart is like happens to be oriented this way and my local forward is this, but based on my input, let's just say I'm a little turned offset, right? But based on user input, they're just pressing up. They're trying to change direction. Basically, we're moving this way, and user input saying no, I want you to go straight up. We have a difference in these two, so this might be a dot of like maybe like 0.5. And then if the cart is, say, going this way, and user input is saying go this way, so velocities, this is where we're really drifting. We're going this way, but this would be 0 because we're 90%. We're 90 degrees off. But now I think about it, this is velocity, not user input. So based on like everything, the user pressing buttons and the cart having some inherent momentum, and that's what the ending velocity comes out to be. So whatever that ending velocity mixed with the local forward, this is our orientation. But if this is saying like just dot it, and if this is greater than 0, like any of these situations means we could go into drift, which to me doesn't really make sense. Like this is definitely a drifting situation because you're offset from where your velocity is pushing you. Even this to me looks like drifting because again, there's pretty strong difference between where you're currently oriented and where your velocity is throwing you. But this to me doesn't seem like drift because I'm moving in exactly the direction that my car is going. So I don't know if I agree entirely with this. I might say like if the dot is between like negative 0.5 and 0.5, I don't know when you would ever be kind of pointing backwards and against your velocity. So I might say, hey, if you're between 0 and 0.5, then you can drift. Otherwise, you can't drift. But anyway. So somehow once the drift becomes true based on this. And I need to go back up to fixed update, gather inputs. So tick power-ups, apply power-ups to our final stat. So I guess if somehow, I'm not really going to go into that deeply right now because I'm not interested in power-ups. I just want to see how the car is moving. But I guess this is checking like if you just picked up a power-up and it's going to mess with your stats and stuff. But I'll look at that later. So apply our physics properties. So take the transform, invert the transform point at the center of mass. Okay. I'm not going to get, this is like transfer. This is a transfer matrix operation. And I'm not going to get that into it with you because as long as you can understand like positions and scaling as vector 3s and that even rotations behind the scenes are quaternions, but there are like some nice helper functions to just think of them as vector 3s. Those are like a big step forward in your development. But ultimately, a transform component with the position, rotation, scale is actually what they call a transform matrix. It's a 4x4 matrix, and everything behind the scenes is stored and manipulated with this matrix. It's called linear algebra, and it's all these. You can figure out anything like from this 4x4 matrix. You can get the position, rotation, the scale, both at the local level, at the world level, and it's like that's almost as deep as you're gonna as like if you care to dig into what's happening in transform matrices. And the reason to use the matrices is because you can do the manipulations on the GPU and connect them right up to the vertex shader, and you don't clog up the CPU. But all that's saying here is that transform the position from world space to local space. Okay. So it takes the center of mass, which is usually, if you notice here, rigid body, that center of mass. Usually center of mass type thing is a physics thing. It's part of the rigid body. But it looks like there's some property sitting on this thing that is the transform of it right at the center. The vehicle is the center. Okay. For some reason, they kept the transform out. It's the center of mass. And it happens to be this one right here, the wheel colliders, which is just a little bit up on the Y, which, okay, whatever. So here's like the center of mass for the player cart in general, and underneath it, it's just, this is just a local transform. It's like whatever the player cart root is at, just add a little bit on the Y. And for whatever reason, based on their physics work, they've figured that you should really use that as the center of mass, probably through a lot of play testing, but whatever. So take this position and invert it. Means it's currently recorded in local space, so just pull it out and convert it. And I want to understand the vector 3, the point, the position of this thing. Which is a vector 3. I want it expressed in world space, and then set my rigid body up center mass to that. Which, sure, you could have put the rigid body down on that area, but whatever. It's just a way to like offset the center mass for a rigid body. So int grounded count. So it looks like it goes through all 4 wheels and checks if they're grounded. And what are these? So these are the wheel colliders. So these right here, these like fancy wheel colliders. There is a bool on them, says if they're grounded, if they're touching a collider or something. And then get ground hit. Okay, so I'm guessing a wheel collider has a method on it. Okay, cool. So this is what the actual wheel collider script looks like. That it took a long time to actually decompile it. This is actually a script from Unity Engine, and that's cool that we can open it up and look at it, because normally like their stuff is kind of hidden. But this is just a component that someone at Unity wrote, but to us it's like kind of hidden. But there's a method there called get ground hit, and I'm guessing it just shoots a physics ray directly in negative y. It figures out how far from the ground it is. But in either case, if this is grounded, or if you call this method get ground hit, we say, yep, this wheel is grounded. We look at all 4 wheels and we see how many of them we could say are grounded at this fixed update loop, and calculate how grounded and airborne we are. Okay, so take of the 4 wheels, divide it by 4. So if only 2 of the wheels are grounded, then we're 50% on the ground. And then air percentage is 1 minus that. So if we have 1 wheel on the ground, we're 25% on the ground, 75% in the air. So apply physics, vehicle physics. So there's some field here. it defaults to true. Somebody somewhere must check if this is false or not. I'm not sure where. We could look at the references. And it looks like set can move. Somebody can set this to false or true. Probably depends on like if we're in like a pause situation or something, like should we be allowing the cart to move. So if we can move, let's call MoveVehicle with our inputs. Accelerate, brake, and turn, which is the 3 parts of the struct. Which, why not just send in the whole struct? Why break it up at this point and like have to write that all out? Why not just send the whole struct in there and then you can reference each part as you need to? But whatever. Accelerate, brake, and turn input. So this is I think the big one, right? Yeah. So this is going to take a while. So this is the big meat. This is like, let's move the vehicle. So we're going to take some time with this. And this is called every fixed update. So, float, Excel input. So there's a float, and it's going to be equal to, all right. So they're using a ternary operator. So it's kind of like these are like little if-else statements. It's saying, is accelerate true or false, right? This bool that's coming in here. So is the user pressing up arrow or not? If they're pressing up arrow, there's going to be a 1. Else, it's going to be a 0. So the way that this ternary operator works is there's got to be some type of bool expression. This is a really simple one. It's just a bool, but it can be a more of a complex logical expression. And then what happens is you use the question mark. And if this is evaluated to true, then this whole equation, this whole expression, I should say, this whole expression gets evaluated to this first part. And if this is false, and then we take the second part as the ending result of our expression. So we do a logical expression, and then we have this ternary operator. If it's true, we evaluate to this. Else, and it's a colon, is the else of the situation. Otherwise, it's 0. And then whatever this evaluates to, we subtract. Are we braking or not? Is the user braking? If it's yes, then this evaluates to 1. Otherwise, 0. So for accelerating and braking at the same time, it's 1 minus 1 or 0. If we're accelerating, it's 1. And if we're just braking, it's 0 minus 1 or negative 1. And that's our Excel input. So let's see what else you got. Manual acceleration curve. So, okay. So some float. So transform inverse transform vector. So transforms a vector from world space to local space. The opposite of transform vector. Okay. So there's going to be a vector, which is rigid body dot velocity. So the rigid body, one of the main things it keeps track of is the velocity of the scale object at that moment. And it inverts it. So we go from world space to local space. Sure. Okay. So the rigid body is going to be in world space. But it's like, hey, for whatever reason, we need it in a local space. So remember that this script is sitting here on this level. So if there's anything above it, which there isn't, that there might be a possibility that local space might be different than world space. But we're kind of sitting at the top of the hierarchy here, so I don't think there's any difference. I'm pretty sure local space would be the same as world space at this point, but in any case, we have this local velocity. And then Excel direction is forward, so it's a bool equals Excel input is greater than or equal to 0. So, okay, if this is greater than or equal to 0, which is accelerate or accelerate plus break. But if we have break, this would be false. Local velocity direction is forward. So local velocity, so whatever we calculated here, just give me the z component of it. And set it greater than or equal to 0. So bool. Okay. So if this is greater than or equal to 0. So not only are the acceleration that's coming from our user input, but we also check what our velocity is at that moment. Just remember that the acceleration input is different than what you're currently moving at your current velocity. So use the max speed for the direction we are going, forward or reverse. All right. So float max speed equals, here we got ternary operator. So local velocity direction is forward. And that's this right here. So if we're going forward or not, if we're going forward, then our our final stats, that stats class. So we grab the top speed of that as our max speed. Okay. If we're not going forward, then we grab our reverse speed as our max speed. All right. Because we'll be going in reverse, and then acceleration direction. Okay. So if we're going acceleration forward, then take our acceleration as our accel power, otherwise take reverse. We don't go as quickly if we're going reverse. So current speed. So rigid body velocity magnitude. So remember, velocity is a vector showing us like how much we're moving in 3 directions. And speed is sometimes nice because we don't really care, like 60 miles per hour. We don't care about the direction. We just want to know how fast you're going. So that's the magnitude. And there's a lot of variables being declared, floats and bools. And this thing is being called every fixed update loop. I usually am hesitant to declare the variables within a method when the method is called so much, because I'm not sure what type of impact that's having on performance. But maybe, hopefully, these are declared once, and the compiler is smart enough to say, hey, since this method is like called over and over and over again, don't just like scrap out these declared variables, then redeclare them over and over again. I hope that's not happening. And since there's so much of this here, I don't think so. I feel like you would get really bad performance. We could take a quick look at. There's usually like a little drop down for performance. Stats. I'm gonna click play real quick. So here we have all our draw calls that are going through the GPU. So we're getting 80 frames per second. We got our CPU, our main CPU at like 10, 11 milliseconds, and the threads at 5 milliseconds. No, I think I look at that after class because I don't want to go down another. That's just it. I think I've never seen like so many variables being declared, and I know that this method is called each like every fixed update. So I'm just curious about that, but I don't want to waste my class time on that. But acceleration ramp. So our current speed divided by our max speed. Okay. Our multiplied acceleration curve. So take the acceleration curve, multiply it by the acceleration curve coefficient, which is 5. Okay. Just something they must have with testing found out. We're going to take our acceleration curve. How quickly the cart starts from 0. A higher number means it accelerates faster. Okay, it's a float. I thought it was maybe like an anim curve because it said curve. So, okay, how quickly do we accelerate from 0 when we're like hitting the gas pedal, basically? Then we got this multiplier on it. Sure. So, float lerp, we're going to go whatever this number is to 1, A to B. And then what's our T? How far across are we with it? So this number multiplied by this number, so square it. Okay. So this is like a ratio, like how fast are we currently out of our max speed, and then multiply it again, like square. It's going to be some percentage, like 0.7, and then when it's multiplied by itself, it shrinks down more. Okay. And you want to go from whatever this thing is to 1. Okay. It's just weird that they're lerping. You could kind of, I mean, we do use lerps a lot, and they're using it here just to find if I'm between here and here, how much am I with this? But you can, okay. So is braking. So are we braking? So take our forward velocity direction, true or false, and brake. Okay, so let's say we're moving forward. So let's say we're moving forward and we're not braking. So this would be true and false. So this whole thing would be false. Or, okay, we're saying or. So either one of these could be true, and this would be true. Or we're going backwards because this is negating this. So this would be false. This would be true. In that type, so if we're going backwards, this would evaluate the true, and we're accelerating. Okay. So what a brake means is if we're moving, if we went reverse and we hit accelerate, that would be a brake because an accelerate would slow down our reverse velocity. And if we're moving forward and we brake, that's the same type of scenario. You're like slowing down your movement. You just happen to be going positive Z and hitting brake, or we're going negative Z and hitting accelerate. If either of those conditions are true, we could say that we're braking. And if we're braking, use the braking acceleration instead. Okay. So if we're braking, then give me the braking acceleration from our statistics. Otherwise, we're going to grab the acceleration power, which we've figured out up here. And we have our final acceleration power. And so our final acceleration will be this final acceleration power times this acceleration ramp thing that they calculate out up here. Okay. I think we're finally done with all that. So apply inputs. All right. Turning power. So are we drifting or not? All right. So are we drifting was calculated up in the fixed update here. Yeah, my bad. Wasn't you good? I remember going over this and not liking the dot product. But where was it? My bad. Is drifting. Alright, there's a bunch of drifting. Looks like down toward the bottom of this method. Oh, yeah, MoveVehicle. Oh, yeah. Crap percent. Yeah. Alright. Maybe it was some type of drift that had like the dot thing going I was just talking about earlier, but I guess it was never mind. I guess this is a different type of drifting variable. Oh, sorry. Can you just give me just 1 minute? Sorry, it's my healthcare provider, it's my doctor. Hello? Yes. Hey, how are you? Mm-hmm. Right. Right. No, I don't think. I was thinking back. I don't think so. Okay.